All right, welcome back to 7th grade math, unit 1, perfect squares and square roots, where, once again, you cannot use a calculator in this unit on the SOL. So please keep that in mind and do not rely on that little square root button. In these videos, I think this is the 4th one I've made thus far. I am going to go ahead and make one more after this with a few more practical questions, word problems, and just a quick little summary of the whole thing. So hopefully you'll see it in action. So each of the last 3 videos has been an intro, and then I answered question 1, question 2, and this video is going to focus on question 3. I also gave you in the first video a quick rundown on how to use your multiplication chart to remind you of your perfect squares. You're looking at the diagonal. If you need to go back and look at that first video, please do so. The second video focused on essential question number 1 of what is a perfect square. Question 2 in the third video was what is the difference between squaring a number and finding the square root of a number. And we are now on question 3, essential question number 3. I forgot to write it before I started the video. Essential question number 3 is a little bit deeper of a question. So it's asking you to make some connections. So it asks what is the relationship between the geometric shape of a square? What is the relationship between a geometric shape of a square, a perfect square, and a square root? Again, my handwriting is not the best at the moment on this one question because I'm rushing through so I don't take up too much of y'all's time. But hopefully you'll hear the audio of this and know what it says. So what is the relationship between a geometric square, a perfect square, and a square root? And again, that word geometric just means we're looking at the actual shape. We're no longer talking about squares as numbers, but we're talking about squares as shapes finally, in the sense that you've seen them most of your lives. So if I were to draw a square, let's go here, draw a square, and I'm going to say that, first of all, if you are familiar with your formula sheet, then if you find a square on your formula sheet, which it is on there, then there should be a formula written below it that says A equals S squared. Okay, and then I believe it has a arrow here and an arrow here, and it labels both this top side and this side as S. So what this means, A area is equal to side squared, and we also see side squared, meaning I need to write side 2 times and multiply them together. So if I did an actual example of this, then that would mean that the area, the inside of the square, hopefully y'all know that area means inside. Okay, then if I said the side length of this is 6 and the side length here is 6, then area is equal to 6 squared, which is 6 times 6, which is 36. So that means that the inside of this box is equal to 36. Okay, so a perfect square, the shape, y'all are normally pretty good at telling me this simple fact. So a perfect square, again, we're talking about the actual shape right here, has 4 equal sides. Four equal sides. To find the area, which is the inside, to find the area, and again, this is really just putting into words what I just went over, the inside, but I'm going to make a little connection here. Inside, you square, as you saw in the formula, and you will have your formula sheet on this part of the SOL. You will not have the calculator. You square the side length, which is just multiplying it by itself. Hopefully you will have made your multiplication table. Now, what is inside the square, also called the area? That's the inside of the square. What is inside the square goes inside the radical. Sorry, goes inside the radical. For example, 36. If I had 36 inside the square, then that means I have 36 inside this radical. So the square root of 36 is whatever that side length was. So the square root of 36 is 6. So the square root is the side length. Perfect square is the area. And the square root is your side length. That is the connection between the geometric square and a perfect square and the square root.